All right, guys, we are moving into section 4.7, which is piecewise functions. This is the last section of this chapter. So 4.7, piecewise functions. So a piecewise function is a function that's defined by two or more equations. Each piece of the function applies to a different part of its domain. So we see the example that's shown here where we have f of x equals x minus 2 and 2x plus 1. And depending on the x value, there are different things that are happening here. So what does that mean? So this part of our graph here only exists when our x value is less than or equal to 0. This part of our graph, where we have the equation of 2x plus 1, only exists where we have x values that are greater than 0. So if we look here, we've got the x minus 2 part. This part in here, that's this part of the graph right there. It only exists when your x values are less than or equal to 0. So in that part of the graph right there. Then we have 2x plus 1 when x is greater than 0. So notice that that only exists in this section of the graph when your x values are greater than 0. Okay, so depending on what your x value is, we're really graphing two different functions on the same plane based on the x value that we have. So evaluate the function above when x is equal to 0 and when x is equal to 4. So all you're doing is you're looking at the graph. Now, this becomes a little bit tricky because your x value equal to 0. So there's really 2 points here that we care about. Right? We have this point and we have this point. And both of those are x values equal to 0. Now, we could think about it in terms of looking at the graph, or we could plug into our equation as well. Notice that we have an open circle right here. So if we think back to our inequalities, an open circle really means it's really not a part of the graph. So which is the one that actually counts? It's this one down in here. What is the y value when x is equal to 0? My y value, or f of x, in this case f of 0, is equal to negative 2. Now, I also can just plug 0 into this equation. 0 minus 2 is equal to negative 2. And I get my answer. Part B, couple ways you can do it. You can say to yourself, oh, let me look at the graph. My x value is equal to 4. Where does this graph exist? Oh, it's off it. It really would be somewhere up there. So now I say to myself, okay, I use this graph, or this function here, when x is less than 0, less than or equal to. Well, my x value is equal to 4 here. So I'm not going to use that one. I'm going to use this one here because my x value is greater than 0. It's equal to 4. So I'm going to plug into the actual equation here. So f of 4 is equal to 2 times 4 plus 1. So f of 4 is equal to 8 plus 1, which is equal to 9. So my value is equal to 9 here. So it's all about determining which function you're going to use based on the restriction, this part, that's given to you. And you can look at the graph if they give you a graph to do that, or you can look at the equation. Let's look at this one now. Now we're given 3 different functions. We're saying, okay, and this is where this gets tricky, depending on your x value, and it's always important to look at the restrictions, that will tell you which one of the functions to use. So you're either going to use this function, this one, or this one, depending on what your value of x is. Now remember, this in the parentheses is your value of x. So you're going to use function number 1 when your x values are less than or equal to negative 1. You're going to use function number 2 if your x value is somewhere from negative 1 to 2, not including negative 1 and 2. And you're going to use function number 3 if your x value is greater than or equal to 2. So function number 1, or g of negative 4 rather, your x value is equal to negative 4. So which one are we going to use? Well, I have to look at my restrictions now. Well, I use equation 1 when x is less than or equal to negative 1. Your x is negative 4 here. It's certainly less than or equal to negative 1. So I'm going to use function number 1, and I'm just going to plug in. G of negative 4 is equal to negative 4 plus 4. So negative 4 is just going to be equal to 4, 4 plus 4, and my answer is equal to 8. So it's all about choosing which part of the function you have to use. Number 2, your x value is negative 1. That's a tricky one because it's part of your boundary points. So it could either be example or equation 1 or 2. Well, equation 1 says you use it when x is less than or equal to negative 1. Well, negative 1 is equal to negative 1. So once again, we're going to use equation 1. So g of negative 1 is equal to negative 1 plus 4. That's equal to 1 plus 4. So that's going to be equal to 5. In example 3, your x value is equal to 0. So I use equation 1 when it's less than or equal to negative 1. Well, 0 is not less than or equal to negative 1. I use equation 2 when your x value is somewhere between negative 1 and 2, which it is. So in this case here, you don't even actually have to plug in anything for x because it's telling you right away your answer is just equal to 3. There's no x to plug in, so g of 0 is just equal to 3. Here in number 4, your x value is equal to 1. So once again, we're going to be using our second equation, and g of 1 is also equal to 3. There's nowhere to plug in an x value here because it's only equal to 3. So my answer is just 3. Now my x value is equal to 2. So I have to go back to my restrictions. Okay, I use the bottom equation, example number 3, when x is greater than or equal to 2. So g of 2 is going to be equal to 2 times 2 minus 5. That's equal to 4 minus 5. So that's equal to negative 1. And the last one, your x value is equal to 5. So we have to check. Okay, once again, that's using example 3. Plug in the 5 for x. 2 times 5 minus 5. You get 10 minus 5. So g of 5 is equal to 5. So it's all about determining which equation you can use based on your restrictions here. We'll look at this example in class. Next one, okay? Now you have to graph this. And when you're asked to graph, this is perhaps the trickiest part of this section. Your best bet when you're doing these is to create 2 tables. So you're going to create a table for this graph, and you're going to create a table for this graph. One important thing to note is you're always going to use the boundary point. What I mean by the boundary point, I mean by that restriction boundary point. I mean by that value that's given to you in your restriction. So I'm going to create 2 tables. I'm going to create a table for negative x minus 4. And for my negative x minus 4, I know I have to choose x values that are less than 0. But I'm also going to include 0. And the reason I include that is because I have an open circle at 0, because 0 is really not a part of the graph. So I'm going to include 0, and I'm going to put a little open circle there to make sure I know that that's an open circle at 0. And then I'm going to pick a bunch of other x values, like negative 1, negative 2, negative 3, negative 4. This is my x, and now I'm going to find my y's. So if I plug in 0 in for x into my top equation, you're going to get negative 0, which is 0, minus 4. So you're going to get negative 4. Then plug in negative 1 into your equation. So you have negative 1, which is positive 1, minus 4. So 1 minus 4 is going to get you negative 3. Then plug in negative 2. You're going to get 2 minus 4. You're going to get negative 2, negative 1, and 0. So let's plot that graph, negative x minus 4. So we have the point 0, negative 4, which is going to be an open circle. Why is it an open circle? Because 0 is really not a part of that graph. Okay, it's less than 0. Then I have negative 1, negative 3, which will be a regular point. Negative 2, and -3, -1, and -4, 0. So I have a graph that looks like this. Now I'm going to plot my second graph, which is just y equals x. And this graph exists when x is greater than or equal to 0. So once again, I'm going to start at my boundary point of 0. And now I'm going to pick x values that are all greater than 0. If I plug that in, plug in 0 for x, you're going to get a y value of 0. Plug in 0 for y, you're going to get 1, 2, 3, and 4. So here we're going to have a closed circle. Why? Because 0 is a part of this graph. Then I'm going to have 1, 1, 2, 2, 3, 3, 4, 4. And there's my graph. Okay? Questions on that one? Oops. All right, now I have to write the piecewise function for each of these. So when we're writing a piecewise function, we're going to follow the model that we have here. We're going to write something that looks like this. So y equals, and we're going to have our brackets. And I'm going to start by writing the restrictions. So this graph that I'm looking at that I've circled in red has a restriction of x less than 0. How do I know that? Because I know at 0, I have an open circle right there. My second graph, which I'm going to circle in green, has a restriction of x greater than or equal to 0. Now I have to write the equations of these lines. So how do I write the equation of a line? Well, I need the slope and I need the y-intercept. So for my red line, I can easily see that my y-intercept is right there at +3. And my slope, I'm going down and to the left, or I can think of it as up and to the right. So I'm going up 1, right 1. So it's 1 over 1, or a slope of 1. So what is my equation going to be? Y equals 1x plus 3. So when you're dealing with these problems, it's easiest to find the restriction first, and then create the equation of the line after that. Here, in our green graph, we know that the slope and the y-intercept, let's find both of those. So your y-intercept is at -1. Your slope, you're going up 1, 2 over 1. So 2 over 1, or 2. So what is the equation of that line? Y equals 2x minus 1. So when you're dealing with these problems, step 1, write your restriction. That's the right side. So you're going to write your restriction based on x, based on the domain. Then you're going to find the slope and the y-intercept. And you're going to write in y equals mx plus b form. For each part. Two more examples. We'll take a look at those in class. And we'll look at the word problem examples in class as well. Okay? So important stuff here. Make sure that you have all the notes down and all the examples, and we'll see you in class.